In this video, I'm going to demonstrate some tracing problems that have functions in them so that we can really focus on the flow of control that programs have. So here's our first example. In general, it's a good idea to give your functions descriptive names just like you do variables, but for tracing questions, we tend to let them be a little bit more vague so that we can really focus on what's happening. So we've got one function called function f that takes in two parameters, integer a and integer b, and returns an integer value. In main, we have three integer variables, a, b, and c. So we're going to keep track of those. A is equal to 2, b is equal to 4, and c is equal to 6. So that when we print the values of a, b, and c, we've got something that we can use to keep track of what those values might be. So remember, most tracing questions are focused on what the output is going to be, and the output is the result of any print format functions. Since C is a compiled language, everything's going to start with main. Main's the only function automatically called from the compiler. So we're going to start with main. We're going to declare and initialize integers a, b, and c. And then we're going to print them. So our first output is really easy. We'll print the values of a, b, and c to the output screen. So a is 2, b is 4, c is 6. Then we'll start changing them. So we can see in this line, c is assigned the value that is returned from function f when f is called with values b and a. So control is going to pass from main to f. So we'll go into function f. F has local variables a and b, which we can see in their formal parameter list. So these formal parameters become the local variables for f. So f has variables a and b. A is the first parameter, so it will have this value. So that will be 4, because b is 4 in main, and 4 is what we pass as the first parameter to f. The second parameter gets the value of a. So after our function call, we've passed control to f with the values 4 and 2 to be in this order, 4 and 2. So now we're ready to execute inside f. Now a, local to f, is assigned the value of b plus 6. So we'll grab b in f and add 6 to it. Then b in f is assigned the value of a minus 4. So we'll take a in f and subtract 4. Then we're going to print the values of a and b inside function f. So we'll grab these local copies, a and b. A is equal to 8, b is equal to 4, and we're going to print that out. Then we're going to return the value of a plus b. So we'll add the two of them together and return that value right here. So 4 and 8 is 12, which means c is assigned the value 12. So c in main is assigned the value returned by f, which is 12. So that the next time we print here in the main function, we're going to print the values of a, b, and c as they are now. With pass-by-value functions, which these are, we can only modify one value, and that's with the assignment statement that we return. So even though we passed b and a to the function, these values in main are not going to change. Now we have our second function call where a is going to be assigned the value that is returned by f when given parameters a and c. So we'll trace f again. The first parameter gets the first value. So this a will get the value of a from main. The second parameter will get the second value. So local variable b and f will get the value of c from main. Okay. So we'll trace inside f because we've passed control from main to f with this function call. And we'll say a is equal to b plus 6. And b is equal to a minus 4. Print those two things. And return the value of a plus b. So we're going to add 18 and 14 together to get 32. And we'll return that to main in this location. So a is assigned the value returned by f. So a is now equal to 32. So we have our final print statement with our values in main. B has not changed. A and C have changed because they participate in these assignment statements. So the final output for this program is what we see over here. Let's do another example. This one's set up similarly. This program also has a function f, but this function takes in 3 parameters, a, b, and c. It also returns an integer value. So when we're using it in main, we can expect to see it in an assignment statement again. When we start tracing our program, we're always going to start in main because C is a compiled language, which means main is the function called by the compiler. So we'll start at the top of main where we declare integers a, b, and c with initial values 2 for a, 3 for b, and 1 for c. And instead of a print statement, right off the bat we have an assignment statement. So C is going to be assigned the value that is returned from f, where f is given these parameters. Parameter 1 is a plus b, parameter 2 is a plus c, and parameter 3 is b plus c. So this gives us a demonstration of how we can use an expression as a parameter as long as it evaluates to the same type. Well, since a and c are both integers, a plus c will be an integer, and since this is an integer, all of those match up correctly. So the first parameter of f is a, and a will take on the value of a plus b from main. The second parameter will get the second expression, which is a plus c. And the third parameter will get the third expression, which is b plus c. So when we start our first pass-through of f, local variable a will have 5, local variable b will have 3, and local variable c will have 4. And then at the beginning of f creates a variable sum, which is the sum of a, b, and c. Then in f, we're going to compare that to a couple of different things. We're going to check to see if sum, which is 12, is less than a times b. Now a times b is 15, so it is. And we're going to return the value of a plus b, because this return statement happens right here. Remember, return is the end of the function, so we're not going to check anything else. 12 is less than 15, so return a plus b. So return 8 and assign c that value because of this assignment statement. Then we have our first print statement. So we're going to print the values of A, B, and C as they exist in main. This is immediately after our first assignment statement. So C does not have its initial value, it has the new value that it's been assigned. So we're going to print A is 2, B is 3, and C is 8. Then we have our second assignment statement. So B is going to be assigned the value returned from F when given A, B, and C as its parameters. So we can pass in the values from main to F in the same order, A, B, and C. So A will be 2, B will be 3, C will be 8. The sum will be all of those added together, and then we'll do our comparisons again. Because this function call passes control back to F. F creates the sum is the summation of all the values, and now we'll check to see if 13 is less than A times B. A times B in this case is only 6, so that's not true. 13 is not less than 6. So we'll check the next one. This is 2 times A times B, so 6 times 2 is 12, but 13 is not less than or equal to that. So instead we're going to return A plus C to main. So B will get the value 10. So that when we do this print statement, we'll print the values from main. Both B and C now have new values because they've both been assigned a new value from the function calls. So now we have another interesting example where A is assigned the value returned from F, where F is given parameters A, B, and the value returned from function F when F has the parameters C, B, and A. So this is a nested function call. We've got to evaluate the results of this function call before we know what parameter to pass in for parameter C for this function call. So we're going to do the inner function call first. And its first parameter is the value of C. Its second parameter is the value of B. And its third parameter is the value of A. So we're going to go to F. We'll create a sum. The sum is all of the values added together. And then we'll check it. So 20 is less than 80, A times B. So return A plus B, which is 18. That return value goes to where the function call is located. So that return value is going to go here. This function call returns the value 18. So this function call is now A, B, and 18. So now when we do the outer function call, we'll call F with these values. 2 from main, 10 from main, and 18 from this inner function call. Okay. So inside F, same story as always, we'll create the sum. And then we'll compare that value. 30 is not less than 20. So try again. 30 is less than 2 times 20. So we're going to return B plus C. And this time our return value goes here. So A is assigned the value 28, returned by F. So in our final print statement, we're going to see A is 28, B is 10, and C is 8. Each of our initial variables has changed once from each of these assignment statements. So the final output for this particular example are these lines that we see here. So 3 print statements, 3 output lines. Okay, let's do one more example. This particular example has 2 functions for us to take a look at. There's F, which has 3 parameters, and G, which has 2 parameters. So this will give us a chance to trace 2 different functions. In C, we always start at the top of main, so we'll find our main function. Main creates integers A, B, and C, and gives them initial values 1, 4, and 2. Okay. We have an assignment statement, so A is going to be assigned a new value based on this function call. So we're going to call F. F has parameters A, B, and C, so we know it's going to have local variables A, B, and C, where A, the first parameter, is the result of a different function call. So we have to call function G before we can continue. So G has parameters A and B, so it's going to have local variables A and B. Remember to match up the order. The first parameter is B, so A in G takes on the value of B from main. And the second parameter matches the second parameter, so B, local to G, takes the value of A from main. Then at the beginning of G, we create an average, which is A plus B divided by 2. Now there's integers here, integers on both sides of the division sign, so we're going to do integer division. So even though 5 divided by 2 would normally be 2.5, when we do integer division, it's just 2. Then we'll check these statements down here. If A is greater than B, so 4 is greater than 1, return A minus the average, so return 2. And that gets returned, remember, to where the function was called. So instead of this function call now, we're going to pass 2 as the first parameter for function f. Our second parameter is a plus c. And our third parameter is b plus c. So when we start function f, we'll have a is 2, b is 3, and c is 6. F creates this integer sum, which is the summation of all of the values. And then we check to see if sum is equal to a times b. A times b is 6, which is not equal to 11. So we're going to return instead a plus c. This return statement will take us back to the function call for f. So we're going to replace this whole expression with the value 8. So a is assigned 8. Then we have our single printf statement. So the output will be the value of a, the value of b, and the value of c. One assignment statement, only a has changed, so a is the result of this function call. A is 8, b is still 4, and c is still 2. There's one final example I want us to take a look at. Each of these are specifically designed just to be tracing questions so that we can follow the flow of control and deal with nested function calls and make sure we match up our parameters. This next example is an actual program. And the code, you can find a copy of the code in your recommended textbook. This is the parallelogram program. So there's some context clues right away. We have two functions, print characters and print parallelogram. So you can probably start to guess that the purpose of the program is to print a parallelogram. And we can confirm this in main. Here's our main function. Main creates three variables, ch for character, height, and width. There's three prompts for the user. Which character would you like? What's the height? What's the width? So that'll give us the height and width of the parallelogram. So the only thing left in main is to call the print parallelogram function. So we're going to do an example. We're going to let character be the ampersand symbol. We're going to let height be 3 and width be 2. This is a nice small size for us to trace. So we know we're going to call this print parallelogram function with these parameters. So we'll pass to print parallelogram the ampersand symbol, 3, and 2. So if we go over to the function print parallelogram, we can see C should be the ampersand, height will be 3, and width will be 2. This function creates an integer I and then has a for loop. So I will start at 0, and as long as I is less than height, remember height is 3, we're going to do the following. We're going to call print characters. First, we call it with an empty space. So on our first call of characters, C is an empty space, and N gets the value of I, which is currently 0. So we've made a function call to print characters, passed as parameters a blank space, and 0. So C is equal to this blank space character, N is equal to 0. Print characters creates its own integer I. Remember, each function has its own variable space, so they can duplicate names. And it has its own for loop. As long as I is less than N, print a copy of C. Well, since N is 0, this very first time we're not going to enter the for loop. So I is 0 and 0 is not less than 0. So do nothing, return. So we're going to return to here, basically. And our very next statement is to call print characters again with C and width. So we're going to pass in C and width. So now we'll run our for loop. I starts at 0. As long as I is less than N, print a copy of C. So now that we're going to have an actual print format function execute, we're going to have some output. I is 0. 0 is less than 2. So print C. I will increment to 1, and 1 is less than 2, so print C. I will increment to 2. 2 is not less than 2. So exit the for loop and return. So we'll return to where the function was called, so right about here. And we're going to print a new line. So we'll go down to the next line. Then in print parallelogram, we're operating in this for loop, so its local variable I is going to increment. So it will become 1. And since 1 is less than height, height is 3, we're going to repeat these statements again. We're going to call print characters with a blank space and I, which is now 1. So we'll call print characters again with space and 1 and run this for loop again. So we create integer I is 0, as long as I is less than n, print a copy of C, which is now a blank space. So we're going to go to here, since 0 is less than 1, and print 1 space. Then I will increment to 1, and 1 is not less than 1, so we'll return. And we're ready to run our second call to print characters. So now we're going to call it with C and width, which is 2. So now we'll run the for loop again where n is 2 and C is ampersand. Start I at 0. As long as I is less than 2, print copies of C. So we're going to print 2 copies of C. Before I increments to 2 and 2 is not less than 2, we exit the for loop and return. So then we print a new line. Now, I will increment at the end of this for loop, so I will become 2. And 2 is still less than height, so we're going to run one more time. There's one more iteration, since 2 is less than 3. So we're going to call print characters with a space and I, which is 2. So that when we run this for loop, we're going to print 2 copies of C, so 2 spaces. So 2 spaces before we return. And we call print characters again with C and width. So we'll send in C and the width, which is 2. So we're going to run this for loop again and print 2 copies of C. Then when we return, we'll print a new line. And I will increment to 3, which is not less than height, so we'll exit this for loop and return. Remember, that takes us to the function call that was original, so we're going to return to here in main. Then from main we'll return 0, which is the exit for our program. So our output is this 2 by 3 parallelogram made of our symbol ampersand. One of the cool things about practicing with tracing programs on your own is you can always plug them into the compiler to see what they actually behave like. So here's a copy of print parallelogram where we can give it the same values that we just traced to double check that we traced it correctly. So here's our symbol. Our height was 3, our width was 2, and we should get, as our result, the same parallelogram that we made when we traced the program. And we can also check it with some other inputs if that was something we were interested in. And our program prints a parallelogram with whichever height and width is specified using whatever symbol the user enters. Remember, tracing is a very important skill for a programmer to have. Being able to read code makes the debugging process much faster, and if you encounter an error, you can find it and fix it that much quicker. So I hope you found these examples helpful for your own tracing practice programs, and I will see you next time.